Hi, this is Rubat Khan, and welcome to lecture 5.4 of Intro to Algorithms. Today's lecture is about finding time complexity of recursive problems. So before finding the real time complexity, let us do a little recap of what recursion is. So we are given a function t. So let me fix this a little bit. Okay, let's start again. So in recursion, we're given a function, let's call it t, and t takes an input of size n, then does some work, and then call t inside t with a reduced problem size. So what happens in a recursion is we're given a function t that takes some input of size n, does some work, and then recursively call t with a reduced problem size. And this continues until the base case. And what is the base case? Base case means the problem size the problem size or the problem reaches its smallest unit, and it cannot be further broken down. The time complexity of recursive algorithms depends on two things. The first one is by what factor the problem is decreasing. Second, the time complexity of the work. By work, I mean this portion. So the time complexity of recursive problems depend on these two factors. Now let us look at a small example. So we are given a function t that takes an input of size n, and this is the base case check. If n equals 1, we return 1, else we return n times t of n minus 1. So this is basically factorial. We know factorial of 3 is 3 times 2 times 1, and this is factorial of 2. And this is the code for finding a factorial of a number n. Over here, at each step, the problem size is being reduced by 1. And the work done here, so the work done is this base case check, this return, else, this multiplication, all this work done take constant amount of time. Okay, now the time complexity is So before finding the time complexity, let's draw the problem how it's breaking down from n. So at the beginning, the problem size is of n, and we do a work done which is time complexity of 1. At the second step, the problem size reduces to n minus 1, and we do some work which takes constant amount of time. In the third step, the problem size becomes n minus 2. So at each step, the problem size is decreasing by 1. And we again do some work which takes some constant amount of time. So at one stage, it will reach the base case, and the problem size at base case is 1. And over here also, we do some constant time work. Now the total time complexity, or the time complexity, is addition. So let's say time complexity is addition, or the sum of work done at each step. So over here we have 1 at each step, so we need to add them up. So we need to add them up. Now, how many steps were there? So this is basically number of steps times 1. Now we need to find how many steps were there. So by number of steps, I mean how many steps it required for the problem size to break from n to 1. So if I look at this, if I look at this, we see that the problem size is decreasing by 1. So it means in order for the problem size to reach 1, it required n number of steps. So if n was 5, let's prove it. So n minus 1 is 4, n minus 2 is 3, n minus 3 is 2, n minus 4 is 1. So it takes 1, 2, 3, 4, 5, n amount of steps. So we can write n times 1, and we know that the time complexity will be in terms of n. So we have n over here. Therefore, we can say that the time complexity to find factorial recursively is big O of n. Although finding the factorial was a simple problem, not all problems will be this simple. So what we usually do is we find a recurrence equation. We find or we generate a recurrence equation and solve this recurrence equation to find the time complexity. Now, how to find the recurrence equation? So recurrence equation is nothing but expressing this entire work mathematically. So we have a function t that takes a problem of size n initially, and at each step what it does is it does some work of time complexity constant, and then call the same function again, t, and send a reduced problem size, and it's n minus 1. So the new problem size is n minus 1. Or we can say the problem size n is broken down into 1 and n minus 1. So this is 1. So this is of size 1, and this is of size n minus 1, but we call the function t on this subproblem. Okay, so this one we don't have to add it in the equation. So the recurrence equation for this problem to find the factorial is Tn big O of 1 plus Tn minus 1. And in the next lecture, we will see how to solve these recurrence equations to find the time complexity. Thank you very much.